right, we are going to move on, and we're talking about the true definition of a function mathematically. So we've created equations of functions where we had f of x is equal to the rate times x plus the initial amount. Today you're going to identify different parts of a function. So a function is like an equation, and there's parts to it. You have the domain. Domain means it dominates. Dominating, the value that dominates is x. Because y depends on x, doesn't it? So it's like x rules the world and y changes however x is changing. The range is how you change. What changes is the y. And a relation is a set of points. That's what you've been, when you see things like 0, 0, 1, 1, 2, 2, that's a relation. It's just a collection of points. Here is the definition of a function. Remember that everything depends on x. X dominates, x is the domain. So for every x to be a function, for every single x, there is exactly one y. Okay, so think about an equation, y equals x plus 2. For every single x, if I put a 2 in, y is going to turn to a 4. It doesn't turn into anything else. It follows that equation. If I put a 3 in, y is going to turn into 5. If I put a 6 in, y is going to turn into 8. It means that no matter what I put into the function rule, the equation, I get exactly one y. Okay. Next one, these are different ways to write ordered pairs. So an ordered pair is x, y. X is a domain, y is a domain or range. So it can be domain range. X is what you input into an equation, and y is the output. It's what comes out. X is independent, y depends. So those are all different ways. X, y, domain range, input, output, independent, dependent. Those are all ways to identify a point on a line. All right. So now that we know that, one of your learning targets today, I'm going to give you a relation, which means a set of points, and your expectation is just to identify the domain and identify the range of those sets of points. Okay, a little rule when you do that, you list each domain and range separately and only once, meaning if there's 2 3's for an x, you only use one of them. There's 2 3's for an x, you only write 1 3 down. Okay, you don't repeat. So, how you set this up, you write domain and you write range. And then you have those little like bracket things. It's like a notation for a set. If you forget what a domain is, well, what is domain? Is the domain x or y? X, domain, dominate. X is the dominating one. So X is my domain. So I go ahead, and you don't have to write down X, Y, but if you sometimes mess it up, because I even saw in the graphs that some of us mixed up your X and Y. X is always first. Remember, dominates, domain. So I have a 3, I have a 4, I have a 5, and what's my last domain? 7. It's as easy as that. All you have to do when it says identify the domain, look and write down the x's. Domain is x. Range is your y. To identify the range, I'm just going to write down my y's. I have a 4, I have a 7, I have a 9, I have another 9. I don't write that one again. I already wrote a 9 down. So So that's my domain and my range. All you do is write the number that's being represented and make sure you only include it once, even if it's repeated. Not that hard. It's not like you have to apply major algebra for this. You just have to identify. That's a level 1 thinking. Domain, range. Is domain X or Y? It's X. X is first. Oh, this should be a comma. X, Y, X, Y, X, Y, X, Y. So my X's are first. So I have a 6. I have a 4. I have another 6. Do I write it down again?
No.
Nope, I do not repeat it. So I scoot on and I have a 5. That's my domain, my X's. What's range? Say Y.
Y.
Oh, good. Yes, range is Y. Range is the Y value. Okay, so my different ranges are 5, 3, 4, and 8. So that is genuine learning target, and I have seen MCA style questions like this where you're given a set of relation, you're given a relation, which is a set of points, and it says identify the range. That means find all the Y's. It says identify the domain, find all the X's. All right, that's learning objective number 1. Learning objective number 2 is to identify if a relation is a function. Not every relation is a function. A function is defined as for every x, there's one y. For every single x, there's one y. If an x goes to 2y, it is not a function. So how you identify if it's a function is this thing called a mapping diagram. What you end up doing is connecting x to its corresponding y. Okay. So here's how you set this up. I'm given 2 relations here, and I want to know, are these a function or not? A function is that each x goes to exactly one y. You're only looking at the x's. You do not care about the y's. You're just checking to make sure that each x goes to exactly one y. It's not a function if x goes to more than one y. I don't know why I have this. Oh, it's all grouped together. But it looks weird because now it's a t-chart and we don't know which one's a function and which isn't. But you're going to see how we set this up. Okay. So we have a domain and a range, right? Domain, range. Domain x, range y. And we create these little, this is the mapping diagram. You create a vertical section that you can isolate your domain and range in. And I write all my x's in the domain. I have a 3, a 4, a 5, and a 7. And then I write all my y's in the range. I have a 4, a 7, a 9, and then another 9. I already wrote a 9 down. I do not rewrite it. And now I connect my x. This is where you start mapping. Mapping is like the connection. So my 3 goes to 4. What does my 4 go to? 7. See how they're connected? They're the same point. 4 goes to 7. What does 5 go to? 9. What does 7 go to?
9.
Okay, that's a mapping diagram. Now what you do with the mapping diagram is analyze your x, because according to the definition, each x has to go to one y. How many y's does the 3 go to? 1. The 4 goes to 1. The 5 goes to 1 y. The 7 also goes to the 1 y. We don't care that they go to the same thing. We just care that they only go to one thing. So this is a function. What I'm looking for and what I would do if I were you, I'd highlight. My eyes, when I do this, I'm looking to see, is there only one thing connecting? You can barely see that. Let me try green. No, green won't work. But I'm just checking the lines to see, does each X have just one line connected to it? I don't care about the Y. I care about the X. Okay, the next one. I have to isolate my domain in my range. So I set it up. And you don't have to put these, some of you will just write them down. That's totally fine. I'm just used to making little boxes. Domain is X. So I have a 6, a 4. Do I write this other 6 down?
No.
Nope, because I already did. And a 5. My range are my Y's. I have a 5, a 3, a 4, and an 8. Now I map. So I go back to the point. The 6 goes to a 5, the 4 goes to 3, the 6 goes to 4, so I gotta go back to the 6 and go to the 4, and the 5 goes to 8. And then I identify, is this a function? It says each X goes to one Y. So I look, how many Y's does the 6 go to? 2. So this made it not a function. It's not a function because the 6 went to 2 different things. It should only go to 1. Okay. Okay, so the next one, I went ahead and pre-filled out our domain and range charts. Now I'm going to do the mapping, which is connecting. 3 goes to 5, 4 goes to the 6, 8 goes to the 9, -1 goes to the -4. I'm looking to make sure that my X's go to 1 Y. So I check here, only one line is connected to each X, so this is a function. Okay, the next one, I'm going to start mapping. 3 goes to 0, 4 goes to 0, 5.5 goes to 1, 9 goes to 1. I'm looking only at my domain, my X. Each X should have one line connected to it. I have only one line connected. This is a function. Okay, next one. 2 goes to 2. 3 to 4, 2 to 0, 4 to 4. I'm looking at just my X's. Right there, I have 2 lines connected to my 2. That is not a function because you should only have one line connected to each X. Notice I never looked at my Y's. I always look at just my X's.